Thanks a lot, guys. Hi, everyone. I'm Viktor Tron from the Tron Foundation. And over the next 30 minutes, I would like to share a way of seeing decentralized storage, in a kind of manner that I think is missing from the conversation. Basically, not as a single product, but as a spectrum, from free all the way to fast, not only because these are the two favorite four-letter F words that I wanted to put in the presentation title, but it's actually all the way like to various layers and properties. So what are these? So what we have is basically storage is not one thing. That's the premise. It's like at least these two we know about, that like at least these four different productoids. And I'm going to argue that even if you conceive of decentralized storage as being basically part of the backend of Web3, and even if you think about just one dApp or one application, you're going to realize soon that maybe even within one dApp you typically need more than one of these. And therefore, your favorite platform that you want to use may have to cater for all these. So what I'm going to talk about is basically how Swarm can cater for all these product needs. And what we're going to do is despite all the variety, we say that every behavior in decentralized storage we reduce to these two primitives. One of them is propagation and the other is persistence, let's call it that way. They're sufficiently sophisticated words that they can serve as technical grounding, but they're actually about just moving data, and the other one is to keep data. And everything else in this talk is just built on top of these, and no extra layers might be needed. Maybe a third one is going to be just added, but that's a kind of economic primitive, really. All right. So let's map these primitives onto the resources that they actually consume or they depend on. So what the users view is that bandwidth is needed to push and retrieve content, so basically to upload to the decentralized cloud storage, and download it. And for the storage, this is that they have to specify something not to be forgotten. The operator's view is that they relay packets or relay particular messages in the protocol, and that's how they use the bandwidth for. And they also kind of reserve some disk space for storing stuff. And as you see, the quality expectation of the two are very different as well. One is kind of just maybe low, one need to be good quality. For the propagation, need to be low latency, high throughput, and well connected. And for the storage, you need to be with large capacity and some redundancy and probably durability. So in another way, we can conceive of these two resources also in a physical way, or maybe in also borrowing some sort of finance allegories. One of them is flow and the other is stock. And as you see, the nature kind of reflects this. Time-wise, the propagation is instantaneous, so better to be treated as almost real time. Persistence is extended in time. The scope of propagation is local. You can locally decide where to propagate certain things, and persistence only globally evaluated, and you don't even know where things are stored necessarily. And there's also this notion of duo, basically, which will be maybe important in later of this talk when we talk about how to compensate for the other primitive. Basically, by frequent retrieval, you can compensate for persistence, and with dispersed storage, you can also compensate for retrieval. But let's jump into a bit more about the incentives. So these two resources are accounted and settled in very different ways. So as you see in decentralized storage, you want to think of incentives which are basis for self-sustainability in the network. So as you see, bandwidth is essentially instant gratification, which allows it to be accounted and settled in a tit-for-tat manner between peers. And that's Swarm uses a kind of check exchange for this, which is kind of a micropayment system. We don't need to go into the details. And on any kind of miscounting, you can just use disconnect, and that's how you punish things. And the unit that you use is basically BCC per chunk per proximity or the bin, which is per the Kademlia bin, basically. And storage, on the other hand, is promissory in nature. That's why it needs an escrow payment, and it's when you use postage stamps. So postage stamps is basically you buy the right of issuing stamps on the blockchain with a batch of stamps, and then you can issue them. You can link to them you can stamp one chunk at a time, and this kind of provides some sort of revenue to this contract, and that revenue is basically redistributed to those that play the game, basically the node operators. And if they don't, then either they're slashed or frozen, or if they kind of misbehave and don't store the stuff, don't order the stuff, or don't synchronize, or if they kind of storing stuff that's not supposed to be stored, etc., they might be punished. And the unit here is like BSD per chunk per block, obviously, like how the unit is calculated. So as you see, there's different units, different time scales, and very different enforcement mechanisms. And so basically two different markets, two separate markets. And so this is where the system stands today. Basic bandwidth incentives are done quite uniquely in Swarm in a way that I don't see in other systems done. That's basically you account and settle the cost where it's actually created. And on the other hand, storage is based on this redistribution game. You're redistributing content to those that contribute to storage in a fair way. So let's consider some of these tiers, like what these primitives will allow you to have. So let's consider the free tier first. At the moment, you have time-based settlement, which is essentially conceives of bandwidth as a renewable resource that you can replenish over time. And if you want a free bandwidth, then basically you have to rate limit the flow. Yeah, rate limit it's kind of a throttled experience. And I think it's a bit messed up. I think it's really bad UX. That's especially for new users who want to use the free tier just for trials and maybe Swarm demos or things, and introduce to the system. They really typically you don't want to show a kind of really a rate limited, and you really don't want to show them side that's kind of worse quality than what they would have, because you want to convince them to have some retention of the network. You want to convince them to stay. Yeah. On the storage side, the postage stamps have also a kind of price oracle, which are acting on supply and demand in the neighborhood. So that's how the postage stamps are priced. And there's no equivalent on the bandwidth side for this. At the moment, it's very much fixed price, and these are not good. And also, what I'm gonna present, or what I'm gonna propose, is that after a reframing of these problems, what you're gonna have is basically this change view. What you're gonna have is a proper true free tier in the storage. Basically, that's his insertion to cache. Maybe that's a good question to ask in the question and answer section, like why this is definitely needed, and you also have free tier in the propagation, but that free tier is kind of just provided as an X layer. In fact, what we do have is abolish the genuine freeness of propagation, and this is because even if persistence was free and as well as bandwidth, then when you upload stuff, you would have the immediate spammability problem. So you could just spam the network and basically expunge the entire cache with whatever spam you're pushing to the network. And therefore, so either the bandwidth or the postage has to be non-free in a way. But we can still provide the freeness with limited credit, basically a lending construct. And it's basically the same primitives as you see, but a much simpler model and much cleaner UX. And the rest of the talk is about how to make it work in practice and what kind of other constructs we can kind of mix from these, really. So continuity services. What is continuity? So continuity is basically well, let's first focus on the two storage types that's kind of emerges from these two primitives dichotomy. So cache is related to propagation. Basically, the nodes, it's in the interest of the nodes. It's basically their best strategy to cache the content that goes through them. If stuff is retrieved from, like, basically backwarded from the forwarded requests, they backwarded the chunks in the kind of retrieval protocol. You'd cache them, and therefore you can serve them to other requesters later, and so it's in your interest. And also the other way to get into the cache is, of course, to let the postage stamps expire. And from the node operator's perspective, if the postage stamp expires, then you put the chunk in the cache. On the other hand, reserve is basically a persistence commitment. So you dedicate your disk space you reserve it to a particular set of chunks which are postage stamped, and you keep them until the postage stamp expires. Now, so basically you have from the user's perspective, the cache is something that defines the stampless upload. So basically it's the target of the free tier, and the reserve is something where you have to pay not to be forgotten, stay retrievable. So let's see what the pain points of the UX are, which kind of might break the adoption. Really, it's not really the core protocol that might be lacking some feature, but maybe some sort of UX pain points that still prevail. So what's happening here? There's essentially three UX pain points here that I mentioned. One is postage anxiety. What does this mean? It means that the postage stamps, as we said, the price hierarchy is basically changing the price as we speak, like basically based on supply and demand, or supply per demand, and therefore it can change the price, and what's currently deduced as the price of the storage rent on every kind of round of this redistribution game might change. And since the expiry is quite naturally defined as expiry happens when you deplete the funds on your contract, or sorry, on your batch, on your stamps, basically, then basically the TTL, or time to live, or expiry date, is basically going to be uncertain. It's quite annoying because people obviously want to know like where the stuff is expired. And it's also not very compatible with this upload and disappear scheme that we always say. Upload and disappear, by the way, it doesn't mean that what you upload disappears, but that you can disappear after you upload stuff. Yeah. So upload and disappear is basically not really compatible with like anxiety that you always have to look whether your postage stamp expired. So you really want to have either a certain TTR or maybe some sort of subscription-based idea that our favorite centralized providers also have usually. The other one is the checkbook friction. So what the checkbook friction means that in terms of bandwidth, I mean, you have two options if you want to pay right now, because like remember, there's no free bandwidth anymore. So there's the kind of earn to spend idea. So you have to work your way to the swarm, and first, like if you don't have any cash or any BSD, you just have to work first and create some income, and therefore that's how you monetize and deploy your contract, and then you can spend from it. Or, but it's a bit annoying that you don't have a zero cash entry, where you would where you could just even you can onboard the user, and at the same time use your bandwidth to retrieve stuff. And the third one is like basically the underlying reason for one is that you have the BSD price moves, and the users want kind of predictable pricing really, and they don't want to. And also, there's also kind of another annoying fact. It's also the token price is volatile. Solving that is a little bit a different problem. But even if the token price is kind of fixed or considered that a non-problem, a non-issue because you have your BSD, then even the unit price of storage might change, and you don't really want to be exposed to that kind of commodity price volatility. Yeah. So protocol is fine. The user experience is what breaks adoption, and basically what we have to. So which way? Okay. So we have to provide a continuity service. That's what I call it, continuity, which basically guarantees some sort of outcome for the user and helps with the bootstrapping and the smoothing of the volatility, and also with the zero cache entry. In the case of bandwidth, basically this gives zero cache entry and with a non-throttling experience, and also kind of continuous access regardless of what kind of cache situation you're in. And on storage, you also can solve the upload and disappear problem, basically make sure that the TTL, the time to live, is certain, and people and not anxious anymore. There's no this post-stems anxiety. Yeah? So basically, then as the no exposure to the commodity price volatility. And so when we think about it, there's a genuine user need, and on the other hand, there's a genuine hodler's need to have some sort of productive options for your capital, and luckily these meet. So basically, if you reframe it as a capital availability or capitalization problem, then you can really have a solution which provides some sort of restaking, or basically tie up your liquid stake VCZ into this subscription contract, and ultimately kind of guaranteed some sort of profit, which is basically the premium that absorbs all this risk. So it's basically more like an insurance arrangement, and you can in fact characterize this scheme with basically have three rows. You have subscribers, underwriters, and executors. Underwriters that are the kind of holders who would hold the capital anyway, and they want to seek like active yield on their holdings, and they essentially happy to take on the boundary risk and kind of almost guaranteed profits. And the subscribers that are the users which want to control and want to know volatility and predictable pricing, etc. And you want the executors, which are essentially like smart contracts themselves, or like things that they just have to act deterministically, even if they have some off-chain component, but they don't have to have any sort of off-chain trust. And most importantly, they are not assumed to be node operators. Yes, because in fact, what's the ultimate interesting thing is that a decentralized network is mostly aligned in their incentive is the node operators pay the stake and take the profit from whatever ultimately the network is making profit from. But in fact, if it needs some sort of high stakes, or if you need to provide capital, it's most of the time we run into the problem that those that hold the capital and would be able to pay stake, they are not the same demographic as the ones that would be geeking around and operate nodes. So it's actually an interesting problem. And if you want to directly solve this, might not be easy, because the stakeholders, it's like basically a moral hazard, there a bit. And on the other hand, if your protocol stays this pure and basically all the contribution that these continuity service providers do, and doesn't require online presence in this particular network, the peer-to-peer network, just the presence, and everything is executed by the smart contracts. And then what happens is this suddenly become very, very useful for the users. Okay, so basically continuity services where hodlers and users needs meet. Yeah. All right. So what I have to convince you is that both bandwidth and also storage, the risk is bound. It's kind of all kind of juggling around with this phase of how the risk is bound. It's not necessarily obviously, but if you basically cap the credit and you make some assumptions about the rate of people who would default, the rate of people who would not have kind of this incentive to be retained in the network, then basically the loss can be modeled as some sort of has to be limited, and also with postage stamps top-ups, you can imagine that during the limited time of a few runs where you can guarantee the price, the price hierarchy cannot move the price so much that it's not going to remain bounded. And if the risk is bounded, then of course every loss of risk, or every type of risk in terms of the potential loss can be factored into into the premium that you pay. Basically, it can be risk-adjusted profits. Okay, so so this is what I just said basically, and if you want to take away basically the single economic takeaway message from this talk, then basically this should be the page for it, and so as I said, like bounded risk basically. Let's say storage tiers. So first let's consider like first the cache. Let's revise again. There's cache. That's also in the interest of the nodes to keep, and that's why it's free. And what is guarantees is that you can earn cash, basically earn the bandwidth incentives from serving these things, which are kind of not necessarily at the place where they would be normally stored in terms of the storage model of Swarm. Yeah. So storage model of Swarm works in a way that in the same place that you would normally find information about who hosts the data in normal DHT, like in BitTorrent, IPFS, etc., you'd find the actual data. So basically it's a very strict storage model, and also kind of what makes it possible to have a load balancing between the nodes is actually the property of addresses, which are kind of hashes, content addressed chunk store. Content addressed chunk store, then that's what makes it possible to have a load balanced. That's what makes it possible. But what enforces it is actually the postage stamps, the batches, which are kind of global in a way that if a postage stamp is a volume of stamps that you can issue, but if you issue some stamps to this part of the network, then you also have to issue that part of the network. Yeah, this is basically as if a book of stamps in real life letters would be something like, if I send two letters to my mom in Budapest, I have to send 2 letters to my uncle in Miami. Yeah, same time, or lose it, but then in that case, the skew is kind of exponentially costly. Yeah. So basically, cache and reserve, the paid storage. So the reserve is the paid storage, as I said, and basically what it guarantees is it guarantees some sort of hot availability and basically an RFOD local replication. Now, what we want to also kind of include is code storage. But let's first see like what we call pinning. So what pinning is like cached. So there's cached content, reserved content, and pinned content. Pinned content is what you kind of pin to your local node, or any node operator pins to their node, and serves it from there. So what you need for pinned content to be served is a modification for the retrieval protocol, which currently is when you request a chunk, then the chunk's address, of course, is taken as the ultimate destination that the request has to be reaching, and it's served by anyone on the way from the cache, or ultimately the one that's close to the chunk, and the chunk is stored wherever to whichever node is closest to it, and that's in its reserve. Yeah, and the pin content is exactly use the same routing. It just use a different source or input for what the routing is. Basically, host. Let's call it host-based routing. Yeah. So the pinning comes basically in 3 flavors, and so let's keep this, and maybe I can return to this in the question section if you really want this kind of routing issue. But the pinning basically comes in 3 flavors. So if you think of it as also free tier in a way, that if you operate a DApp, you may be storing some content for your users, and so you just pin it, and therefore, like storage of it, you can rely on your own infrastructure in a way. You trust yourself, and it's a different trust model, but it's the same retrieval mechanism and the same kind of caching above it. So basically, if you think about it, it's a little bit better than like just a Web 2 solution of a single server serving it. You can also make it a bit better by still having a private distributed cluster, which kind of maybe the best is that you actually distribute your content in a balanced way, and you assign some sort of servers to maybe to like an 8-way partitioning of the address space, and just run an 8 cluster or an 8-node cluster, and basically serve the content from that. It's still private and it's distributed, but it's still kind of a simple private, simple trusted model. But what you can also have is a decentralized service network, which I would call cold storage is a public pinning network of Swarm. So basically what you can have is a smart contract that allows you to maintain a balanced set of nodes, each serving a particular partition of the address space. So basically, as you see, for example, in this particular, well, that would be 60 nodes partitioning all the different exhaustive list of 4-bit prefixes of the address space, and anything that starts with these prefixes would be stored by any particular node in this balanced network. So and the actual 1 minute, yeah, okay, or 2 maybe, and so but until 30, yeah, until 30, and then 30 minutes, yeah. Come on, you took 15 minutes to set it up, so yeah. I really want to have at least 10 minutes for questions, so yeah. And I started when it was 25, so I'm 25. Can I have like maybe 5-10 more minutes? Yeah, thank you. Okay. So I quickly run through this. So basically what you gain with this extra pinning service is basically that this can act as a cold storage in general, but also as a cold storage backend that will allow you to seriously reduce the cost for node operators. How do you reduce the cost of node operators? Well, you actually increase the storage that links to one node, but you cannot really extend it forever because it depends on how much requests they get. So depending on how Swarm is used, whether it's kind of always used as just like an archival style of storage where things are stored but not really retrieved, like for example encrypted user backups, or it's used like for videos live streaming, which is kind of almost no storage is needed, everything through cache, but it's actually a lot of retrieval is happening. So there are two types of use, and the kind of the ratio of these kind of use cases are not very clear what's going to happen. This might even change over time. Anyhow, the other ways to reduce costs is obviously reduce the local redundancy. So even if you want to with the current system, if you have 4-fold redundancy, no matter whether you can reach the economy of scale of like an S3 cluster, like proper Amazon cluster, then you can't really offer a better price because of the 4-fold replication. Obviously, it's like a huge extra cost. But as we know, we have erasure coding, and with erasure coding, it becomes possible to actually not even have at all any availability in any one particular neighborhood at the same time. So it allows for a gradual reduction of the redundancy factor, local redundancy in one network. And actually, the cold storage can be used as kind of guarantee the retention for the single primary neighborhood, so primary address neighborhoods. And it's very important to have primary and secondary addresses. Maybe a question section. I would also like to maybe answer this if someone asks, like why it's needed to be separate. But the cold storage, like kind of as a fallback recovery mechanism to retrieve the chunks by their secondary address. Yeah. All right. So just a few slides and then I go to questions. Yeah. So basically, yes, this I can skip definitely. And just a few words about the arbitrage pricing, because I mentioned that it's very important to have a proper pricing, because like Swarm has this idea that so actually the decentralized storage and in fact this Web3 backends should not really be served as a as a kind of marketplace for storage, really, because it's a market, but the pricing should be centrally kind of set in a way, but centrally for the whole network, and therefore you don't have to bootstrap the markets. But on the other hand, you have to have some sort of very clever pricing mechanism that's in the case of storage is very clever set to supply and demand. But in the case of what's the way to set the price of bandwidth, for example. But anyway, so what we have is basically a system where you can the markets decide in a way, and no governance, no committee, and no discretionary ways to basically no voting on prices and stuff, and the way it would work is that operators arbitrage. So there's supply side and demand side arbitrage. So supply side arbitrage operators would have these options to dedicate their disk to cache, in which case they earn from the bandwidth, or so these are the kind of forwarding nodes that just act as forwarders of content, and they just serve whatever, they just reserve whatever data it's in their cache. And there's the reserve nodes which play the redistribution game, and there's pinning stores which prove whatever you want to pin and serve from there, local disk, or have the code storage mechanism. And also there's demand side arbitrage, in which case you can divert to the cache, to the reserve or pin, depending on your actual storage need, or depending on this kind of dual. So this has a self-regulating self-regulating nature of this whole thing. So basically, if the storage gets expensive, then people just lean on the cache and kind of arbitrarily, maybe regularly retrieve that content, even if they do not necessarily need it, and therefore the operators rebalance it, because that will the storage price down. And the other way is like if bandwidth gets expensive, then they can hire the level of erasure coding, which makes the dispersion happen. And quite interestingly, if you disperse the content more, in Swarm it means that you pay less for the bandwidth on average by the unit of a chunk. So it's actually very, very interesting how this rebalancing can actually provide ways for both users and operators to influence the price if they think it's kind of mispriced. All right, and this is my conclusion, is that you have these basically three commodities. I mean, two of them are kind of primitives of how you move data, how you keep data, and the continuity is basically it's an economic primitive of how you create an underwriting service from basically holdless capital, and helping some of these outcomes to happen, some of these guarantees. And basically the full composability happens this way, that the subscribers buy continuity, outcome what the fixed priced, underwriters supply the capital, and operators basically supply the resources and take the revenue from whatever the subscribers pay for ultimately. So hopefully it's lower friction, and hopefully it will give some higher adoption for the network. And what we basically ultimately conclude is that this will give a different definition of Swarm. Basically, it's a market for bandwidth, storage, and continuity. And that's what I want to conclude you with. And if you want to have any questions now quickly, I don't know.